I'm talking today about the journey to microservices from a startup perspective. And when we talk about microservices, we hear and read a lot about success stories from very large organizations such as Netflix, Amazon, eBay, Spotify, just to name a few. And when you look at those success stories, you might end up saying, well, that's great, what's there, just let's copy that. Well, the problem is that what works for one company well might not work for you. So the journey to microservices is different for every company. And as Adrian Cockcroft, the former Netflix chief cloud architect, said, is if you just copy the results, you might miss and skip the process behind. And this results into the fact that you will not receive the results that you expected. So the journey to microservices has to deal with trade-offs. There's no fast golden rule that you can easily apply. Just to give you a brief overview of what we do and who I am. I am Susanne Kaiser, the CTO of Just Software. We are located at St. Pauli, Hamburg, here in Germany, north of Germany. And what we do is at Just Software, we develop Just Social. That's a B2B product providing app for communication, collaboration, and an integrated solution to simplify and support teams working together more efficiently. And let's go first, before I go to our journey, let's go to the beginning. A couple of years ago, when we started our startup, everything was really small and cute in a way. So we were working with one team on one collaboration product, which was implemented as one technology, was implemented as one code unit within one technology stack. So the thing is that after a while, everything was evolving. So our team got bigger and bigger. We added more features to our product, and the number of users increased. So that's supposed to be very fantastic, but on the other hand, we reached a point where everything was feeling kind of clunky and slow. From the organizational perspective, it was the case that everything took too long to get things done. For example, our meetings, our discussions, our decision were more time-consuming than before. And the thing is that also that we had not really well-defined responsibilities. No one felt responsible, for example, when a bug arose. So the process was becoming slower and slower, and our productivity suffered. While adding more and more features to our product, the usability became kind of complex. And so the usability and user experience suffered from continuous feature amendments. So instead of solving our users' problems efficiently, we were kind of confusing them. And also related to our software architecture, everything was tied together, so we had no opportunity to release independently and fast. And when we do a change to one part of the system, it might have affected also the other part of the system. So there was kind of need to evolve that we need to shift and split things up. So we had the vision that we then split our one collaboration apps in multiple smaller collaborations apps. So taking care of a specific problem and solve this one very well. And so we established separate apps for sharing documents, for communicating in real time, for communicating, for exchanging knowledge, information, and news. So the idea came up to have different collaboration apps for a specific use case. In the meantime, we were also splitting our one big team in smaller teams, and with a long goal, with a goal in the long run to achieve autonomous teams with well-defined responsibilities. Because what we want to achieve is that every team can work on different parts of the systems without affecting the other system or without affecting the other teams. So what we did is that we then assigned to each team specific parts of the specific collaboration apps so that they can develop independently, work independently on the product itself. So, but we still have to face that we still have a monolithic software architecture. So can we reflect also that we have achieved in our organization structure and our product now along our software architecture? So we wanted to split then our software architecture in microservices, because to receive autonomy, you had to get rid of your dependencies. And so at first glance, it looks pretty easy. Well, yeah, let's go ahead. Let's introduce microservices. But the problem that arises is that microservices come with complexity, and this complexity might not be obvious at first glance, because now you're communicating over in a distributed system. You're now communicating over the network, and the network itself is unreliable and slow. So your request could be very slow, and you can, for example, wait indefinitely for a response. It could block your resources, and it can also fail at any time. So you have to add complexity to handle your failure. And also, in a distributed system with microservices, you are partitioning your data. That means that you are losing your transactional consistencies across services. So you have to deal with eventual consistency as well. And since you're now not only dealing with one monolith, but instead with multiple moving parts, your operational tasks are getting more complex. So monitoring and deployment is getting more complex. And also, like, debugging is becoming is tricky, because you have to now to figure out, like, you have to consolidate your logs across service boundaries. And in fact, when you communicate over the network, you have to establish APIs and how to make sure that these APIs do not introduce breaking changes, so that they then result in a brittle system. And along with all these complexities is that your skill set and also your tools are different than in a monolith. So this has to be adjusted as well. And another question that arises, okay, in the monolith, you always have the authentication or authorization in one place. And now if you deal with multiple parts, with multiple microservices, how shall the authentication authorization be handled? And for sure, to develop efficiently, you don't want to deploy all these microservices in your development environment. Instead, your development environment is more complex than in a monolith world. There are not only complexities that come along with microservices, but also with the transformation phase from monolith to microservices. Because untangling a monolith is really, really hard work, and it's really time consuming. So the transformation process takes much longer than anticipated. So when we started with it, it took at least double the time that we had originally anticipated, and we also missed deadlines. That was a very, very big disadvantage. And also, like, if you have a core functionality with a lot of dependencies, it's not really easy to untangle that one. And one thing that you need to consider is that you still have a running system. It's a brownfield project because you have your monoliths, and you have to maintain and run it while you are transforming it. So you have to share your resources in terms of capacity, but also in time. And which is also very important is that all involved parties has to be on the same side. They have to agree and be on board that you are going to do this path, that you're transforming your monoliths into microservices. Because if you are not on the same board, then it's much more time consuming. Well, reflecting all these complexities and challenges, you might end up saying, well, is microservices world or microservice architecture good for me? Well, it depends. So definitely don't partition without a good reason, and it's not a good reason just to introduce it because it's trendy and hyped right now. And you need to definitely find a good reason to say, well, we would like to go this path. And for us, the reason was that it was organizational driven, because we're splitting up our product, but also our teams into smaller teams, and we want to have them working on a different part of the system at a different speed, and we want to make them, we want to enable them that they can make their own decisions, how to implement it and when to deploy it. So we want to release changes quickly and independently without affecting the entire system. Well, when you have decided, well, let's go this, we have found a lot of good reasons to start with it. Now the question arises, like, how to start? How do you have this huge monolith in front of you, and like, oh gosh, where can I just pull out a single part of it? And what we did, before we did it, we had to keep some key concepts in mind that is really important for doing this step, because the key concepts of modeling good microservices is that you have to guarantee a high cohesion within the service itself and a loose coupling between those services. If you don't follow these key concepts, then you won't achieve the benefits of microservices to have independent parts to be developed and also released. And that means, for example, if you change a part of your system, you don't want to affect the affected other parts of the systems. And if you, in terms of like high cohesion within the service, it means that related behavior shall sit together. So when you change this behavior, you want to modify it at one single place. You don't want to change the behavior at a totally different part of the system, because this means that you have to rebuild and redeploy all the services that you have changed, and then your deployment process is tied together again, and that's exactly the opposite that we want to achieve. So loose coupling and high cohesion are very important for keeping in mind while extracting microservices out of your monolith. And I was talking about high cohesion and related behavior shall sit together. And one thing is that you can then try to identify the bounded contexts. I guess there's a workshop on Wednesday talking about domain-driven design. And it's kind of a principle from domain-driven design that you try to figure out the boundaries where a specific responsibility is sitting in, so a specific behavior is sitting in. And you want also create a kind of like clear understanding what shall stay consistent and which part of the system can be developed independently. So these bounded contexts are very important for extracting microservices out of your monolith, because they provide a kind of seam where you cut out the microservices from. And for us, the bounded contexts were our collaboration apps. And so we were thinking, okay, let's start with it. And we have product-driven bounded contexts. And so we started with extracting one collaboration app, and that was our Just Drive application. And so what we did is the Just Drive application collaboration app is taking care of document management. And so what we did is that we established this or implemented this as a coexistent service to the monolith. And it's not an exact equivalent to the original functionality, but instead it has more features and instead has its own different user interface, because we were working on UI and UX improvements, and also has a different data storage. So what we did, and we built our own service as a coexisting one, but from scratch, which was not good, by the way. And so what we did, so this is then that the Just Drive app is then has a data authority over the documents, because you're exchanging documents in our Just Drive app, and it keeps the data authority on the documents. That means it's the only service that can read, but also write on this data. And for each document, you have an author. And the author is information, it's a profile information, it's an extract of the profile information. And to avoid that you retrieve or every time when you're displaying a document, the profile data from the monolith, because that's the one that has a data authority over the profile data, and to avoid requesting this profile information every time you're displaying a document, we are keeping a redundant copy. It's not an exact copy, it's an extract of it. So, and this is okay as long as you do not undermine the data authority of the monolith. That this one is still the one that modifies the profile data. But now you have a new complexity because you have to make sure that these data is in sync. And to do this, you have to establish a kind of syncing mechanism. What we do is that we are using asynchronous communication style between the monolith and the new service, and that is our message broker. So we're using Kafka for that one. And so whenever a profile is updated in the monolith, it gets published to the message broker, and our monolith is then subscribing to this event and updating its replicated data accordingly. So, well, that was good at the first part of it, but after a while, it took too long to get this extracted, because what our problem was is that we did too many steps at once. So we established a new user interface because we were working on our UI and UX improvements. We also established a new data structure because we had some requirements that our document data structure is obsolete and we have to add some new structure as well. And we also introduced new technology. And in the meantime, we still have to maintain our system, and we have to extend our skill set accordingly to match all these complexities. So it was really heavy undertake, and we decided, well, this is not the way that we can extract our services. It's really time consuming, and it's really frustrating because you're not getting results very quickly. So we followed different strategies then. So with the next collaboration app, we're splitting them in steps, and we were zipping it from top to down. And this is probably something that works for us very well. I don't know if it works for others very well, but for us it was a good approach, because when the next service that we were focusing on was the Drive, the chat communication system. And what we did is that we were extracting the web app first, so introducing, moving the web client to its own service, and introducing then a REST client and a REST API to retrieve the data from the monolith. So that's only that's not the final process. It's just the start of the extracting process. But this allows us to develop on the web app independently and deploy it independently and iterate on the UI independently. So we get fast results. That was helping us a lot. So the next one then is that we are then zipping it a little bit more down, and then we came to the business logic. And so when extracting business logic, it's kind of more work to do, because you have to untangle the dependency in the monolith. And untangling the dependency in the monolith means that the interfaces that we're talking to your new service has now to be addressed as APIs then. So you have to establish APIs, and if it's a bidirectional communication style, then you have to introduce them on both ends. And so this kind of like, yeah, more work to do than just extracting the web user interface. So, but what we still see here, that's at this step, that they still share the same data storage. So when coming to the next step, we were splitting the data storage as well. And if you do this, then you, as I said in the very first beginning about our Drive app, you want to keep data redundant, because you don't want to request the monolith for every information of the other domain in a synchronous way. So we would like to keep data redundant, and this means that we have to keep them in sync, that we have to establish a mechanism to keep those data in sync. So, and here again, that's the asynchronous communication that we introduced then when we split the data storage, but also communicating over Kafka to publish modification events. Okay, the question in general arises like, which one of this bounded context shall we use first to extract a microservice out of it? And well, there are kind of like rules, not really rules, but kind of like ideas how you can do it. The first one is like, go for the low-hanging fruits, use the one that are easy to extract. And these are mostly those that have either not so coupled in the monolith itself, that has very little dependencies, or that are already communicating asynchronously. So, and if while you are starting with those that are easy to extract, you can learn while you go. So that means that you can extend your work skill set during the extraction process, and also collecting, gathering experience in microservices, but also in the transformation process itself. Then another idea to pick those that could be good candidate for the next step of the extraction process is that you identify those that are giving you the most benefit. For example, these are those that are, for example, changing frequently. Because if you extract those, you can develop and deploy them independently and release these changes, these frequent changes, independently without rebuilding and redeploying the entire system. So it gives you a lot of benefit. And the other one is identify those modules in your monolith that are using different resource requirements. For example, is this one taking a lot of disk space, or is it other taking a lot of memory consumption? And you can then split those services in order to have a system that you can easily scale, because if you extract them in an independent service, you can then scale it independently. And then another thing is, stop making the monoliths bigger. And it's kind of like, very tackling, like, okay, we have to meet a milestone, just add it to the monoliths. But the problem is here, while you're carving out your bounded context from the monoliths to make this monolith shrink, you're then adding new functionalities on top of it, and so the transformation process itself is slowing down because your monolith is not getting smaller. And so approach could be then to implement new features as a microservice, and whenever it's applicable. So, and after you have extracted your services, which was also very, very important, is that you get your CI and continuous integration and continuous development delivery pipeline ready. Because you have to dealing now with more moving parts, and it's crucial to establish automate testing, automate delivery, and so for every deployable artifact, you are establishing your own pipeline, and this pipeline looks like a monolith, but what we are reflecting in this monolith and in this pipeline for microservices are the CDC tests, the consumer-driven contract tests. And what they take care is about your API, because now you are working in a distributed system, and your microservices are working over in API or communicating over an API. And the problem, the complexity that could happen is that you introduce breaking changes unconsciously, and then this results in a brittle system. So the consumer-driven contract tests, they let you identify potential breaking changes. And what we use is a test framework called Pact. Have you heard of Pact before? Is someone using Pact? Okay. Because Pact allows you to define a consumer contract. And a consumer contract is a negotiation between consumer and the API provider. And this consumer contract is recorded in Pact, for example, when you are running your consumer tests automatically. And what it does is that it generates a provider stub out of the consumer contract and delivers the responses the consumer expects. So you can use it, these consumer contracts at two different levels. So you can use it as a provider step on the consumer side, but also you are generating, on the provider side, you could also generate requests out of this contracts. And to test then your generating requests and test it against your API to check whether the responses are delivered by the provider that the consumer expects. So another question is where you, for example, keep this consumer contract stored. It could be, for example, part of your repository, but what we have established is a Pact broker that allows you, it's a central storage server where you can upload your consumer contract and also tagging and versioning it. So it allows us to access to store it, but also to retrieve it from on the provider side. So what is pretty different for us and also challenging for us, and this is probably not applicable for other companies, is that we are deploying in a polyglot environment. That means that we are providing our solution as a SaaS solution in the cloud, but also distributing it as on-premises products as well. So we have to do a lot. We have to face a lot of trade-offs between those environments, because on the one side we can have a service instance per host, which is guaranteeing isolation for every service instance, and on the other side, on the premise solution, we don't want to have it because we would like to use our resources efficiently. We have to deal with specific requirements or specific restrictions on the on-premise solution. So there we have to deploy it as multiple service instances per host or even per process. For example, if you run different services in your Tomcat application container. And so these are kind of like contradictional requirements, and we have to somehow face it. So what we establish is then that we are providing packages for Debian and also as RPM Red Hat packages. And these packages are then executing Ansible script, and these are provisioning then your system. So whenever you, for example, you install it on your on-premise solution, and you then Ansible takes care that it deploys your microservices on the same Tomcat instead of establishing a new one. So in the beginning, I was mentioning like the complexities between concerning design for failure, and so now we get a little bit into the details, because if you communicating over the unreliable and slow network, you have to take care that you introduce a timeout handling, because you don't want to have requests that are waiting indefinitely or and blocking resources. So you need to establish timeout handling. And in addition, it's also a better approach to provide fallbacks in terms of when your service is not available anymore. Other thing is that you have to consider to keep your system resilient is to limit your number of outstanding requests. And this is kind of like that you measure the threshold, how many requests are outstanding at a specific threshold, then you return a failure response immediately, because it's kind of indication that additional request attempts will be pointless. And also circuit breaker, it's kind of like monitoring your error rate, and it's tracking your number of successful requests and your failed request. And a specific threshold, the circuit breaker kicks in, and from that point on, the additional request attempts will then return a very quick and fast failure instead of waiting indefinitely. So, and the client itself then do after a specific timeout, then do resend this request, and if they were successful, the circuit breaker gets deactivated. This sounds really complex, and the good point is, and you were that there exist libraries for this, and you don't have to reinvent the wheel. So that's something that we also have experienced. Like, oh damn, we have to take care of so many complexities, and we were like kind of like reinventing the wheel in every case. And then we were saying, well, wait a second, we are not the only one having this problem. So there must be libraries around. So we are now trying to establish then or implement Hystrix in our environment. We have not. We're just about to start right now, and so I would be very excited if some of you have already experiences with this library to share experiences with this. And as I mentioned, also one of the complexities is that your developers needs to have full access to a runnable system, and it should be equivalent to your production environment. And so what we provided is that we are, for every developer, we are providing a development environment consisting of a Vagrant and a virtual box where each microservice is established and implemented, so that you can still implement or work on in your IDE, work on your own service, and all the other services are already installed. So your developers don't have to take care of the setup of each single microservice from scratch. So, as a summary, due to the fact that we have to deal with a lot of complexities and challenges, don't partition without a good reason. And if, for example, if you're just a small team and you're always deploying your product as one chunk, and you don't need to release changes quickly, then you can also implement a monolithic a module on Monolith. It's reasonable to do it this way as well. So. But for us, it was very important to release changes quickly, and we also wanted to reflect this in our organizational structure as well. Then, to carve out your microservice from your monolith, you have to identify your bounded context first. That allows you to identify those themes that you can cut out your specific parts of the monolith. And then don't do this mistake that we did in the beginning, because doing too many steps at once. Do the split process and manageable steps. And for example, as I mentioned, zipping from top to down, splitting from top to down, and gather your experience along the way. Get your build and delivery pipeline ready from day one, because this is very crucial in general for development, not only for microservices, but because now you're dealing with more parts, moving parts. This is more crucial than before. And which is also like sometimes you have to keep in mind that it's not only a technical shift, but it's also a cultural shift towards DevOps culture. And if you're not willing to do this cultural shift as well, it won't work for you either. So not only our product, but also our software architecture is made with love, sweat, and tears, to be honest. And now our software architecture is also made with microservices. And thanks a lot.
Thanks a lot for the talk. So there are some questions from the app. One is, how big was the monolith in lines of code?
Less than 1 million. We had roughly 300 to 400,000 lines of code, approximately.
Cool.
The core itself, it's Java. It's running in Java application.
Okay, and the next question is, how long did the transition to microservices take?
It's not finished yet. It will take forever. So, well, we started. Well, it's kind of like there's no real kick-off, like now let's do microservices. It already started with small ones like 1 year ago. But as you have seen, like these like the collaboration apps are more like self-contained systems because they provide their own user interface. They have their own business logic and provide their own data storage. So they are larger parts of it. And this we are doing since the beginning of this year.
Size seems to be pretty important. So how many developers?
Yes, not so many. 11.
Oh, okay. What library are you thinking of using for implementing the circuit breaker?
Yeah, that's the Hystrix that we are now facing. So if someone has experiences in that one or just another one, just let me know. I will be glad to share experiences.
Okay. Did you start to cut and paste the code from the monolith to the microservices for the chat app?
Yes, that's the next one. But we're right now working on it. That's the one that we are zipping from top to down right now.
Any more questions? How big is the team? What are the roles?
You mean like the team size reflecting microservices? It's the same team. So they do both. They do the microservices transformation, but also have to maintain the current system. And that's also the complexity that comes along during our transformation phase journey.
So it's the 11 people that you were talking about before?
Yes.
Yeah, okay, cool. Any more questions? Can you elaborate on the bounded context?
Yes, there is a workshop as well on Wednesday about domain-driven design, the bounded context itself. It's kind of like giving you a kind of a domain model usually consists of several bounded contexts in which each is a model applicable. So it gives you kind of like responsibility. And with its explicit boundaries around it, and wherever you have some behavior that is consistent, that shall stay consistent in one piece. It's kind of symbol, or it's kind of like reflecting that you can put a bounded context around it.
Okay, so I found this one quite interesting. How do you handle deployments while maintaining inter-microservice API consistency?
That's where we introduced the Pact framework, the testing framework. That's the one with the CDC, consumer-driven contract testing test framework. Then we make sure through this framework that we are not introducing some breaking changes, because whenever, for example, when you run your test and you introduce breaking changes, for example, you removed data from your API that your consumer was expecting, then the test will fail on provider side, because the provider still grabbed this consumer contract from the Pact broker server, and then it will identify that that the API that's now actually the current state of the current state of the API will break, because it's different from the consumer contract. That's what the consumer expected.
Yeah, but so I mean, the CDCs will tell you that you have a problem, but how do you solve it?
How to solve it? Well, because we are not that large, we are talking to each other.
That sounds interesting and unusual, and probably solves the problem. Talking about talking, so for talking between the microservices and Monolith, why did you use REST and not a message queue?
We use both of it. Okay, probably I did not point it out. So we have not only synchronous communication, but also asynchronous communication as well. And yes, there are still some REST APIs established between those, and usually it says, do asynchronous communication between across boundaries, and REST is a synchronous communication style, so we are using it, for example, for uploading documents where we sometimes need to have a specific. We're waiting for a specific result on the other service.
Yeah. So a more technical one: how much memory or RAM does a developer workstation need to start up all the Vagrant machines?
It's provisioned with 4 gig. The Vagrant machine.
Okay, so
but
it's just one machine with 4 gig?
The Vagrant box, yeah. There's one machine because it keeps it all in one, yeah.
Okay.
But it's better to have a little more, 6, I would say.
Okay, that's the 5. Any more questions?
Is this on? Can you hear me?
Yes.
Great. So from your slides, it looked like you were splitting the monolith based on product boundaries or feature boundaries rather than component boundaries. And looking back, do you think that was a good idea? Just to give an example, you mentioned this mechanism to copy user profiles to the new service. Wouldn't it have been a good idea to maybe to isolate the user profiles into its own service? Because that's shared across.
Yeah, these are just good starting points, and then you can, from that point on, you can split it into additional ones. So the next one is then the profile service that will be extracted out of it. So that's not, it's just only, reflecting our progress, but it's not the final state that we want to achieve.
I see. Thanks.
Looking back, you talked a lot about complexity, and if you could do it over again, would you start with microservices from the beginning, or was it right to develop the monolith first?
So the question is, would you start with microservices next time around or with monolith?
It depends. It depends on your skill set that you have. If, for example, all the experience that we now gained, we would start with microservices. We would not start with the monolith first, because it's also what you want to achieve. Yeah.
More questions? Okay, so thanks a lot. Thanks a lot for the talk and for answering all the questions.
Thank you.